All right, today what we're going to talk about is we're going to review the line of best fit, which is your regression line, and then we're going to introduce residuals. So on Desmos, that's what I'll be showing you today. What you want to do is put the data into a table, and then before we used to have to enter in this formula for linear regression or this formula for exponential regression, but now they have a little drop-down menu for you, and we'll talk about that in a second. So first what we're going to do is we're going to read the directions or read the situation. Ms. Morton bought $1,000 worth of shares in the Acme Growth Company. The table below shows the investment over 10 years. So we're going to go to Desmos. You're going to enter this information. There's the little plus sign on Desmos, and you're going to enter this in to your X1 and Y1. So that's what I did right here. And after you've entered all this information, you hit the plus sign and did table. You're going to go up to a little symbol. Now I drew this on for you, but it's the line with the little dots on it. And that's going to give you this drop down menu right here. And you're going to select linear regression. When you select linear regression, you can see your graph right here, right, with all the points along there. And then you're going to see the equation. So this is your line of best fit or your linear regression for these data points. So we're just going to round these to the nearest tenth, make that a 7. And then we're going to go ahead and we're going to write that on here. And that's exactly what we did. All right, now the linear correlation coefficient, that's your R value. Remember, the closer to 1 or -1, because remember your slope of 1 or slope of -1, the stronger the correlation. So let's look back here. Our R value, not the R squared, we want the R value, is 0.9984. So that's really close to 1. So this is going to be a pretty strong correlation. And if you look at your points, you notice they're all pretty much on the line or really, really close to the line of best fit. So R value is definitely close. So now we're going to do the same thing, but we're going to do it for exponential regression. So I'm going to go use the same data, but this time on Desmos, I'm going to do exponential regression, and it's going to give you the equation here. Now, it gives you the R squared for this one. It doesn't have just the lowercase r, but the R value here is 1. So we're going to write that down also. And I rounded everything to the nearest hundredth. And now, and again, I put the R value here. So it says which one's the best model. So we want to know which one is closest to 1. Well, this is 1, so that means the exponential's the best model. So now, using the best prediction, which is this equation right here, predict to the nearest dollar the value of investment after 11 years. So we're going to take this equation, and years, those are your X values, the value is your Y. So for years, we're going to plug in 11 to where X is. And when you do that, you could do it with your calculator, or you could do it on Desmos also to use it as a calculator, and you could just do another thing here and type in your equation and it will actually pop up the answer. So if you notice, that's what I did right here. And I used the rounded value since that's what it asked for. And then now I'm going to take that and I'm going to round it to the nearest dollar, which is right here. So you could also do it on your calculator, but since you've already got the information there, may as well do it there. All right, so now what we're going to do is it gives us an equation, and we're going to predict values. So we're going to have the car's miles per gallon can be related to its city, so highway versus city, with the following equation. Find the predicted highway mileage so the car gets 16 miles per gallon in the city. So that's your X. So what we're going to do is we're going to go wherever X is. You've got two options. You can either substitute in 16 for X and solve it, or you can go on Desmos and you can type in X equals 16, and whatever your lines intersect, that's going to give you your answer of 22.364 mileage for the highway. And you're going to go ahead, you're going to do the same thing here with this one, but we want to know based off of this with the IQ score of 90, which is your X. If you did it correctly, you should have gotten 45.98. All right, now we're going to talk about a residual. So this is new, so make sure you write this down on your notes. But a residual is how far the actual Y value is from the predicted. So this is your line of best fit. So this is your predicted. Oops. So that's your line of best fit is your predicted values, but these are your actual. So all these little points right here, those are all the actual data points. All right, and residuals is when we plug in an X value into a line of best fit, we're getting a predicted value, not necessarily the actual value. So what we just did before was we found the predicted value. A residual is the distance from the actual Y value to the predicted Y value. So if asked, all you got to do is plug the X value in and it gives you predicted. And then to find the actual, you look at the actual data points from it. So then do actual minus predicted, and that will give you the residual. So we're going to use the 22.36. This is the predicted from the problem before and with the car. And it says, suppose that a car gets 16 miles per gallon in the city, actually gets 20 miles per gallon on the highway. What's the residual? Well, the actual is the actual data, but we predicted this from before from your line of best fit. So you take those two, subtract them, and you're going to get negative 2.364 miles per gallon. So this is the residual because it's the difference between your actual and predicted. So go ahead for the next problem, you're going to use the 45.98 from the IQ score. You're going to do this, and if you did it correctly, you should have gotten 2.02 as your residual. All right, so now let's look at this next one. This one gives us a graph. So it says the line of best fit. Here's your equation. So in order to find this, it wants to know the residual when X equals 1.25. So we're taking this is your predicted. Okay, so that's your predicted, is all of this is your predicted. So when it's 1.25, I substituted that into here and I got 4.205. So if you look here, 1.25, that's about right where it is. This is a little more accurate, but it's still your predicted value. Now the actual value, when X is 1.25, this is the actual point, which is 2.5. So now we're going to take the actual, and then we'll take the predicted, and then we're going to subtract them, and then that's going to give you your answer. So go ahead, subtract those, and you can get a negative number. That just means that it's much below your line of best fit. Okay, go ahead, and I want you to finish this one. And this one, it says, what's the residual when X equals 0.25? So again, substitute into here, and that's going to be your predicted value. Now you're going to look when it's actually 0.25, and you see that it's at 1. So you would go this number minus 1 equals your residual. So go ahead, finish that one. Oops. Oh, I think that was just the work from before. Yeah, so the negative 2.634. And then here you can see you can graph both the lines, and that's where they intersect. All right. So go ahead, and I want you to try this one. I do have the work here for you to look at, but remember, this is the predicted. And then this is the actual. All right, so go ahead, try this one. And then now we're going to do putting it all together. So this one, we've got another little table here. We're going to go ahead, enter that in. So it shows the mean height of boys between ages 5 and 13. So find the line of best fit. So we plugged all of these into a table, and we got y equals 2.9x plus 33.36. And then to find the correlation coefficient, that's your R value, and that's pretty close to 1. So we're going to say it's a strong positive. And then to interpret the slope, this is your slope. So it's the height of the boys increases because it's positive, 2.29 inches per year. So if you notice, it's y per x. That's usually how I think of it. So y per x. So inches per year. All right. And the y-intercept is your b value, and that's the initial that you're starting or when they were born. So at age 0, they were 33.36 inches. That's a pretty long baby, just saying. But for this data, that's what we'll have. And then using the line of best fit, predict the height of a boy age 15. So to figure it out, we're going to take our line of best fit, substitute in 15 because that's your x value, and we'll get 67.71. And then now, if it's a height of 57 inches, that's your y value. So we're substituting in 57 and you're going to solve it for x. So we subtracted 36.9 or 33.96, and then we divided by 2.29. And then that's going to give you 10.32. So here's all I did is I just plugged these all into there. So plugged it into the table, got your linear regression equation and your R value right there. All right. All right, so now for the next one. Now this is something new. We can find the residuals on Desmos by pressing the residual button with the line of best fit. So these are the same points from before, but now what we're going to do is you're going to look down at this part where it says residuals, and you're going to click plot. So once you click plot, then it's going to take you to this screen. Now, if you notice, this is all new information. And what this means is this is how far away it is from the line of best fit. So this is below it. This is above the line of best fit, above. So if you notice, it's kind of showing you here, if this were to go, it's showing you how far away from the line of best fit that would be. So that's kind of cool. And then what we're going to do is we're going to round all of those and put those in on our table here. Once you know how far away it is from the line of best fit or your predicted values, then you can go ahead and analyze it even more. So it says how many boys were more than 0.4 inches. And it's okay if it's negative. So because it's a distance of it. So we've got 0.5 here, 0.41 here. And again, it's okay that this is negative because it's still 0.5 away from your line of best fit from the predicted. So I've got 3 out of 9 total, which was 0.3333 repeating. And remember, you move the decimal point twice to get 33%. So it was pretty easy. You just had to go through and hit the plot and then under residuals. And then once you got that, it's going to pull up how far away it is from the predicted values. So what you're going to do is you're going to go through, you're going to enter in this table, but I do want to point something out. Is it says let X be the number of years since 1999. So what that means is we're not going to enter in 1999 for the year. We're going to enter in, this is your starting or your beginning. So we're going to cross out 1999, put that, and then this is 1 year since 1999, 2 years, 3 years, and count how many years it is since 1999. And this is what you're actually going to enter on your Desmos. Oops. Let's go here. There it goes. All right. So just make sure you're careful with this. And then remember, once you do it, hit plot. It's going to give you the residuals. It's going to give you all that good information that you need. All right. And then that was a quick and easy way to use Desmos. And then, like I said, I think the newest piece of information is residuals. And just remember that a residual is your actual data minus the predictive data. So that is your line of best fit and residuals.